So in previous lesson, we focused on four main parent functions. It was the constant, the linear, absolute value, and quadratic, and the transformations of those four, what we saw visually happening when we were graphing them in Desmos. Today and over the next four videos, we are going to narrow down that focus into just looking at transformations of linear and absolute value functions. Because if we can understand how to work those transformations and writing those functions without looking at a graph, we can then apply that to any parent function that we come across. And as just a reminder, our transformations were translations that shift movement left, right, up, or down. We have reflections, that flipping motion, and it can be flipped either over the x-axis horizontally or over the y-axis vertically. And we have a dilation, a stretch or a stretch making it go taller and more narrower, and a shrink making it more flatter or wider. So today's focus video is on translations. So we are going to look at those horizontal shifts and those vertical shifts. So I have here a horizontal shift, which we saw when we did the investigation, is the function where the x is added or subtracted to some number. It is grouped together. So again, as you can see here, we have this x minus h. It is grouped within that parentheses. Again, a note that we saw, the value that's being added or subtracted is actually the opposite direction of that sign. And then we have the vertical shift, which will take the value of the whole function and then add or subtract some number. And that adding or subtracting of a number outside the parentheses or outside the x value, that does move in the normal direction. A positive will go up, a negative will go down. And what I have over here in this pink box is going to be really important to remember. Horizontal movements, no matter what they are, any horizontal transformation, that is a change on the inside of the function. It's going to be a change inside with the x value. And that's just a simple substitution. So anything that's horizontal is going to involve a substitution into the equation. A vertical is a change on the outside. So maybe it might be something that I multiply to the whole function or something I add or subtract to the whole function. Okay, so those two key pieces are going to be really important. So as we go through these examples, and I'm only going to do a few of them in the video with you, I'm going to write in blue on one side my thoughts. How do I get about this? How am I breaking down this process to write my new function? And then in other colors, I will actually write the work that would be done to find it. As you go through, if you need to always write the thought and then the work, do that. I'm trying to give you as much in detail as I can to help you out with understanding what's happening here. Okay, so we are going to do just the odds in this video. You guys will have to try the evens, and I will post an answer key later on. So let's get started. So first example, all of our equations are going to mostly be given to us in f of x, and we have to come up with a new function that happens based upon this translation, whatever it is that they're telling us. So in this case, we're translating it 5 units to the left, right? So they gave us the original function is f of x equals x minus 2. So notice it's not the parent function, just f of x equals x. It is of any kind of equation, right? So I have to take this f of x and come up with a new equation that was translated 5 units left. Okay, so I know that this is a horizontal movement. So I'm going to make note of that. It's a horizontal movement. So I know that that's going to be an inside or a substitution. Again, all things I am keeping in my head. And I know that I'm going to be translating 5 units to the left. So a horizontal movement is this one up here, f of x minus h inside, horizontal for h. So my h, if it's 5 units to the left, that is a negative 5 motion. Okay, So now I'm going to come up with a new equation. I can't name it f. You can use any letter you want. I'm just going to use g. So g of x has to equal f of x minus h. And again, I got that from up here. This horizontal shift function is always f of x minus h. Well, I know what h is, right? H was that negative 5. So now I'm going to replace h with negative 5. So f of x minus h is a negative 5. Now I have this. But what happens when I have a minus 5? Well, that becomes a positive. So g of x equals f of x plus 5. Okay, so now this is all thoughts still, right? I'm thinking of how am I going to use this information of translating 5 units to the left and create a new function. Well, the new function is now going to be created by using the original function and substituting, so I'm going to substitute this into the x of the original function, right? So I want to now actually do the work. I'm going to take the original function. So again, blue is my thought. Now I'm getting into the actual work of it. I'm going to make a new function, g of x, by taking the old function, which was x minus 2, and anywhere I see an x, I'm going to replace it with this x plus 5 that I just thought my way through. Okay, so here's my x plus 5. I replaced it into that x position, and then I still have a minus 2. So again, this was x minus 2, and I replaced the x, I substituted that x with what I came up with. The shift of the x values left 5 units was x plus 5. And now I'm just going to solve this. Okay, so x plus 5, there's nothing to distribute, so that can drop down. It's just x plus 5 minus 2. And then I can combine my like terms, right? This 5 and the minus 2. So my new function is g of x equals x plus 3. 5 minus 2 is 3. Okay. I can always check my work. I can graph that in Desmos and see does x minus 2, if I move it up 5 spaces, come out to x plus 3. And I would be able to see that, yes, it does work. Okay. So let's try another one. I'm going to actually do, I know I said I would do the odds, but let's do one that has an absolute value. So let's go to number 4. So now in this case, I have my function f of x equals absolute value of 3 parentheses x plus 2, absolute value of 3x plus 2 plus 4, and I'm going to translate that 3 units down. So now that's a vertical movement, right? Up or down is vertical. So again, if I scroll back up, I'm looking now at this piece. Vertical shifts are f of x plus k, and the k value is the same direction. Vertical is outside change. And again, I can see that. I'm just going to make that note. This is vertical. It's an outside change. And again, the vertical shifts are using k values. So k is going to be 3 units down, which would be a negative 3. Okay, so again, I'm going to do my thought process over here on the left in blue. So my new function, g of x, is going to take the old function, f of x, and then add a k value to it. That is what the vertical function, again up here, stated. I'm using that information. Then from there, I know a k value, right? The k value is a negative 3. Okay, so now I got g of x equals f of x plus, instead of k, I'm going to put a negative 3. And now I have this function. I'm going to clean that up a little bit because we don't like to have double signs. So g of x equals f of x minus 3. Okay. Again, when I look at this, this is an original function. and I'm going to take that original function and subtract 3 from it. Okay, so again, horizontal, question 1 that we just did, that we substituted inside. In number 4, there's no substitution inside. It is a vertical. That is a change on the outside. So you can see I'm just going to subtract 3 from the outside of my function. Okay, so let's get to that. Okay, so my g of x is going to be the original function. So absolute value of 3x plus 2 and then plus 4. I'm going to put that in parentheses as I work this out because it's the original minus 3. Okay, so I'm putting the original function in. Okay, absolute value of 3x plus 2, close the absolute value, plus 4. And then I'm subtracting 3 from it. And now we'll do any work. Again, there's nothing to distribute on that original function, so that just stays as is. Right? And again, I always put the parentheses because maybe there might be something I have to distribute at some point. I don't know. And then I drop down that minus 3. Okay, from here I have a plus 4 on the outside, I have a minus 3 on the outside. I can combine those, and my new function is g of x equals absolute value of 3x plus 2, close it, 4 minus 3 is plus 1. Again, that would be my new function of g with my shift 3 units down. And again, if I wanted to, I could take it and I could then plug them into Desmos, the original and the new, and see, does it actually move 3 units down? And I would see that yes, it does. Okay, let's try one more together, and then I will stop the video and you guys can try these problems on your own. Okay, let's try one more horizontal. We'll do 5. Again, I'm looking at this. I see my original function. Actually, you know what? Let's do number 6 instead. All right, I got my original function, and then I have this translation, 2 units left. Again, for my own knowledge, that is a horizontal. Horizontal is an inside change. Any inside change is going to be a substitution. And I know an h value, horizontal, is h's, and the h is 2 units left. So that is a negative 2, right? Again, if I scroll back up, you would see that general formula. Okay, thought process, g of x, horizontal movements means I take the f and I change the inside to subtract an h from it. Again, I know an h, f of x minus h is a negative 2. And then again, if I clean that up, minus a negative 2 gets us f of x plus 2. Okay, again, this is now a substitution. I am going to substitute this x plus 2 into the x in the function. So, g of x equals the original function where I'm going to substitute in for the x. So, absolute value, 1/3. I then come across the x, because it was 1/3 x, so now it's going to be 1/3 parentheses x plus 2. Close it. Again, I just substituted in for the x in the problem. And then it's just a matter of distributing and simplifying what I can. So g of x equals absolute value. 1/3 times x is 1/3 x, or x over 3 you could do. And 1/3 times 2 is 2/3. And there's my new function. Okay, so hopefully this helps you out a little bit. You guys try those missing ones on your own.